All right. Hi, zoology. Welcome. This is our first screencast that you get to watch. And so, what we're going to do today is we're going to talk a little bit about animal classification. That's it. Later on, we'll do cladograms and organization. So, I would title my notes. You are needing to take notes today over animal classification. Some of this is just review, there is some new information. So, make sure you have that. Make sure you're writing it down. I'll be looking for this from you the next time I see you. So, animal classification. We're in Unit 1. This is zoology. Here we go. Um, so, the first question I would like you to write down in your notes. And so, take a moment. Sometimes you can pause me. So, pause it so you can get it written down. The essential question is, what does it mean to be alive? And so we're going to write down 7 characteristics as to what it means to be alive for all living organisms. You will need to know this. We will go over this the next time I see you, but right now you just need to write it down. So I'll try to take it one by one, but if you need to pause at any time, please do to get it down. There are 7. So again, what does it mean to be alive? Let's get that down in our notes. The first characteristic of life is order. And basically, I'm going to try to summarize. All that means is in order to be alive, you must be made up of cells. Cells. And if you're made up of more than one cell, then the organism has to organize that into like tissues and organ systems. For animals, all animals are multicellular, so they have for the most part, tissues, organs, and organ systems. But one thing that needs to be alive, you could write down order, or you could just write down being made up of cells. Okay. Number 2, you have to be able to change to your environment. So you could write down able to change in environment or adaptations. The individual usually doesn't change, but the population of living organisms can change over time. You have to be able to adapt to environments. If not, then that species goes away. All right, so adaptations are able to change. I would write down one of those two. Number 3, you have to be able to respond to environmental stimuli, which means whatever happens in the environment, you have to respond to it, like get away, know what's good, know what's bad. And so responsiveness is a key to being alive. So either you could write down responsiveness or environmental stimuli, responding to environmental stimuli. Number 4 is maintaining homeostasis, which is basically what regulation means. And that just means to be in balance. You need to keep your cell or mini cells imbalanced and organized in order to be alive. We'll talk a little bit more about that. So maintaining balance or regulation, homeostasis. Number 5, again, remember there are 7. So number 5, you have to have energy processes, which means as a living organism, you have to be able to metabolize. Animals go out and grab food and then they use that food for energy. But all life has to get energy from some source so that they can metabolize to keep them alive. Number 6, growth and development. You have to be able to grow and develop. So even if you're made up of one cell, that cell gets a little bit bigger throughout your life. Growth has to happen. Or as multicellular organisms like animals, they, develop from one cell and they make many cells. And then even once they are like, quote, born per se, for some animals, they grow just like what you have done. So growth and development, or having some type of growing pattern. And number 7, the last one, is then you have to be able to reproduce. You have to be able to reproduce. That means you have to be able to pass your genetic information on to the next generation. All right, these are the 7. Pause if you need to right now. Pause the video. Make sure you have all of these 7 in your notes. I'll be looking for it on the next time I see you. At this point, just take a moment, skip a little bit in your notes. In class, we are going to summarize what it means to be alive. There's a little activity that we're going to do the next time I see you to summarize this. So just make sure you have the 7. Give me a little space in your notes to summarize. We're going to do that in class. And now we're going to continue on with a couple more notes, okay? Here's just a nice little picture of everything that we've talked about. So if you want to pause it and go over these 7 with some pictures, you can. That's up to you. All right, the last thing we're going to look at in this screencast, and so another question I'd like you to place in your notes is, why do we classify organisms? How did we come up with this system? So why do we classify organisms, or how do we come up with this system? So let's write this down. Why do we classify organisms? And it's mainly to make sense of the world, but that's really, I want to make sure you understand like how we went about doing that. So this is the next big picture question in your notes, okay? So if you need to pause the video, you can right now and write down why we classify organisms. If not, we're going to continue onward. Here we go. And so this next slide is just talking about the history of taxonomy. Honestly, you don't need to write any of this down. Just take a moment. I just want you to appreciate that human beings have been talking about classifying life since the beginning of time, since the beginning of humans. The very first person that started to think about this process was a guy named Aristotle. You might have heard of him. He's a Greek philosopher. He started grouping life into categories back in 384 BC, so a very, very long time ago. It was very simple. He didn't talk about bacteria. He just talked about animal, plants, and he thought minerals were alive back then. That's kind of what we thought. It's cool. But we didn't have any microscopes. We didn't even know back then that bacteria were alive. We knew that people got sick, but we didn't understand why. So don't need to write anything down here. I'm just trying to give you like where we're coming from. All right. Now, continuing onward, this is the slide you need to pause and get everything down. Okay, I'm going to talk about it for a second, but definitely pause and get it all down. The father of taxonomy, the guy that came up with the 8 or 7 levels of classification, and then we added an 8th one, his name is, you could call him Carolus Linnaeus, or we just simply call him Carl Linnaeus, and he is the father of taxonomy. This is him, good-looking guy right there. That's what he looked like. He was alive in the 1700s, and throughout his life, he was able to come up with the system that we literally use today. We might have added domain, but he came up with everything. He divided all living things into plants and animals because in the 1700s, we had a pretty good grasp of animals and plants. Again, he did not know what bacteria was, and that's because in the 1700s we did have microscopes. So please note that. I don't know if you remember in your biology days, microscopes were invented. It's just that they were very bad in the fact, or let's not say bad, let's say rudimentary. They were very simple. Bacteria are very microscopic organisms, and so they could not be seen with the microscopes that we had back in the 1700s, okay? So the system that he came up with, again, please pause this, get everything down on the slide, like Carl Linnaeus is the father of taxonomy, and he divided life into 2 groups, plants and animals. I would definitely get all that down, all right? Pause it if you need to, moving on. This is his system, and I think you already have this in your notes. This is what we did like the first week of school, and we went over it a lot the other day, but please make sure you know his system, which is kingdom, phylum, class, order, family, genus, and species. Again, this is the most general to the most specific. Or like, did King Philip come over for good soup? You're going to need to know that. He came up with this system. We call it the Linnaeus system. Pretty impressive. We keep this system in place for hundreds of years. The only thing we added, like it says right here, we did add domain real recently because we kind of understood life a little bit better because of our technology. Okay, so make sure you know the system that we've been talking about was done by Carl Linnaeus. All right, again, this is a slide you need to write down. So get it down. The Linnaeus system, what it does, what he came up with is he came up with this thing called binomial nomenclature. It's the 2-word scientific naming system. So please get that down in your notes. It can be confusing because everything is kind of done in Latin, but this is how we come up with the animals or the organism's scientific name. And we've talked about this before. The scientific name of all organisms is the genus, is always the first part of it, and we always capitalize it. So let's get that down. And then the species is always the second part of the scientific name, and everything is lowercase. Okay? Scientific names are always italicized if we're typing or word processing, like we showed you the other day, or you underline it if you handwrite it, like should already be in your notes. So I'm just kind of going over that information with you. Please take a moment, pause this slide, write everything down. The word that we're kind of introducing to you officially that I'll be going over next class period is binomial nomenclature. So take a moment, pause, get all of this information down. This you don't have to worry about. This is just, again, I'm just going over the history. So since Linnaeus, like in the 40s, we came up with this guy here, Ernest Mayr, that's him, good looking guy. He came up with the biological species concept, which just means like we identify what a species is and what that means. We'll talk about that in class. Robert Whitaker, he proposed the 5 kingdoms back in 1969. So there used to be 2. In the 60s, we said 5. And this is what I learned in college. And then as time goes on, we were like, there's probably more than 5. We now have 6 kingdoms and 3 domains. So just a little history. You don't have to write this down. Just a little FYI. We're going to move on. Okay? You don't need to write any of this down. So why binomial nomenclature? Who cares? You don't have to write this down. This is just kind of confirming what we've done in class. And that is like this animal here. Some people call it a crawdad. Some people call it a crawfish. Some people call it a crayfish. This right here is its scientific name. And you should be able to figure that out because it has 1, 2 names. This would be the genus. This is the species. It's italicized. It becomes confusing if we don't have common ways to communicate with other people. If we use common names, this animal people could think a crawdad is different than a crayfish, which is different than a crawfish, which in fact it's not. It's the same animal. So that's kind of what we did earlier on in the week. I don't think you need to write this down. Why we use binomial nomenclature is because there are problems with common names. And hopefully you get that at this point. So let's write down the 2 reasons why we do this. The problems with common names. Number 1, it varies from area to area, therefore no commonality. That's what I was kind of saying in the last slide. And number 2, it does not specify a particular species. So please pause and get this down. You do want to get this down. Each animal has a unique binomial name, which means scientific name, and it's required by the Zoological Nomenclature International Code. Okay, so do get this down in your notes. I'll be looking for it. Take a moment, pause me if you need to, get it down. So problems with common names varies from area to area, no commonality, does not specify a particular species, hence why we need the scientific name or binomial nomenclature. Here's a nice little picture of what we're talking about. Again, you don't have to write this down. This is just FYI. For example, this is a black bear. A black bear's scientific name is right here, the genus and the species. There's only one American black bear, very, very specific. Now, the genus, Urus, he shares with other bear-like animals like polar bears and brown bears. They are related to each other. They're in the same genus, but not the same species. And then if you go, you can see how this black bear is also related to other individuals in his family, in his order. These are all carnivoras. So he's like related to like wolves. And then in his class, he's related to all mammals, even you. Like there should be a picture of you there. All mammals are related. Phylum, Chordata. And now we're talking about other things that aren't mammals like fish and amphibians and stuff like that. Kingdom, all animals are related to each other in the kingdoms, and then domains if you're eukarya. So again, domain is very general, and then once you go all the way down to species, it becomes specific. So did King Philip come over for good soup? Please make sure you know that, not necessarily this slide. It's just this is a nice little picture, okay? Classifications like an address. And so I like this. If you're kind of struggling, you might want to pause it and just kind of look how it is, kind of like a geographic address. You can look at that. Again, I need you to know the taxonomical information. And then we do have 6 kingdoms now. And even then, it's probably outdated. Like, we gotta talk about that. Even though I'm making you know that there's 6, the only kingdom we want to know is Animalia. But there's talk about having this Protista kingdom going into, like, separating it out. Okay? So there's 6 kingdoms. We're in the kingdom Animalia. You can see that there. And then there are 3 domains. Don't really care too much about domain Archaea, so I don't need you to write down information. Just know it exists. Domain Eubacteria, that's cool. Don't need to write it down. Just make sure you get in your notes. Domain Eukarya, we've written it down before. I would like you to know information about it, so please, like it says, this domain, zoology, will be in the whole year. Please know this information. So we are working in the domain Eukarya. All cells are eukaryotic. You can just write all this information. All kingdoms that are in the eukarya domain are everybody, and the main one that we care about right here are animals. And I'm not saying they're everybody. They're protista, plants, fungi, animals. We just don't have bacteria. Okay? All right. You should be good now. Please make sure, if you need to go back and watch this video again, you should have 2 questions about what is life and why we classify. We are going to, when the next time I see you, summarize why we classify things. I'm expecting you to know about the taxonomy stuff and just about all of the classification systems. So make sure you're able to show me notes. Thank you so much. Can't wait to see ya.